With how vast our galaxy is, it may come as no surprise that there are numerous breathtaking spectacles and facts about it. In humanity's quest to travel and conquer our solar system and eventually our galaxy, we will be introduced to more and more intriguing sights that outer space has to offer. From the immense size of the Milky Way to our inevitable collision with the Andromeda Galaxy. Keep watching till the end to learn more about the most breathtaking wonders of our galaxy. 10. All naked eye stars contained in Milky Way. It isn't that long ago that we used to think of the stars as light leaks in a black curtain, just a little further than we could reach, and heaven was on the other side. In actual fact, all the stars we can see in the night sky with the naked eye, which is around 9,096 or 4,548 from each hemisphere, are contained within our own Milky Way galaxy. Obviously, the biggest concentration of stars we can see lie in the direction of the Milky Way's galactic plane and central bulge, which unfortunately is impossible to see due to widespread light pollution, unless viewing from rural areas on a clear, moonless night. 9. The Milky Way is an estimated 100,000 light-years in diameter, and contains up to 400 billion stars, including our own Sun. In spite of such a huge number of stars, the distance between Earth and even our nearest star system, Alpha Centauri, is vast. Needless to say, comprehending such astronomically large numbers and sizes isn't easy. Can you imagine 186,282 miles, for instance? Of course you can't. And yet light travels that far in a single second, or 5.88 trillion miles in a year. To put things into some kind of perspective, if you were to count at a rate of 1 per second, it would take about 11.5 days to reach just 1 million. Alpha Centauri, our nearest star apart from the Sun, is 25.6 trillion miles away. Good luck imagining. Even with the best technology we can currently muster, it would take centuries to reach our nearest star. The space shuttle, for instance, would take around 165,000 years to reach Alpha Centauri, while the Voyager 1 spacecraft, which has now left our solar system, will not pass other stars for 40,000 years. 8. Just one of many galaxies. The point being that we're really not good at large sizes. The ancient Greeks, for instance, believed that our solar system represented the whole universe, with the sun, moon, planets, and fixed stars revolving around the Earth on a daily basis. In fact, Archimedes estimated the whole universe to be around the equivalent of 2 light-years across, which is far cry from its actual distance of about 14 billion light-years. Size is so elusive that it wasn't until 1923 that Edwin Hubble was finally able to prove that our galaxy was not the whole universe, and that in fact there were hundreds of billions of galaxies beyond our own. According to most recent estimates based upon deep field images from the Hubble Space Telescope, the number of actual galaxies in the universe could be more than 2 trillion. 7. Classified as a barred spiral galaxy. The Milky Way is a spiral-armed galaxy, and as is typical for about 67% of those, ours is barred. It is suspected that such bars are the consequence of a galaxy drawing gas from its spirals into its heart, but as the density of the bars increase over the millennia, their own gravity destroys them, resulting in spirals without bars. It seems to be part of a middle-aged spiral galaxy's normal life cycle to have bars for a while. Some spiral galaxies form by brushing past other galaxies. Their gravities shred their globular shapes and leave long trails of stars that wrap around the remaining large bodies of stars. Often that is the end of it, with their relative speeds so high that they will never interact again. Sometimes there is enough attraction between them that they condense to form a single galaxy. While the above instance is not rare, most spirals are explained by one or both of these theories. You can look at them at your own convenience. The density wave theory, which explains Saturn's rings, explains some spirals, while the SSPSF model explains many others, but the language and mathematics in the latter may be difficult to digest. In any case, the Milky Way has grown by cannibalizing and absorbing other smaller galaxies that it has come into contact with over millions of years, including dwarf galaxies. 6. 2 galaxies could pass right through each other and have no collisions despite their billions of stars. In actual fact, that scenario is rather more likely than an actual collision because of the vast distances between objects, which is a bit of a relief since we and the Andromeda Galaxy are headed for a meeting in the far future. At present, the Milky Way and Andromeda galaxies are approaching each other at a rate of up to 140 kilometers per second, giving them a meeting point of 4 billion years from now. 5. Black hole located at its center, of course. All this matter heading for the heart of the galaxy has to go somewhere. The oldest star in our galaxy is about 13.82 billion years old, forming just shortly after the Big Bang, which means a lot of time has passed, and a lot of matter has gone tumbling into the center of the galaxy. there awaits a supermassive black hole called Sagittarius A, situated 26,000 light-years away from Earth with a mass equivalent to 4.1 million suns, and a source of intense radio waves. 4. Galactic year lasts 250 million years. A galactic year lasts between 225 and 250 million years and are part of the galaxy, since rotation speeds alter depending on location. The best estimate for ourselves appears to be in the 240 million year range, since we're about 2/3 of the way out on the Orion arm of our galaxy. 3. A star maker with between 100 and 400 billion stars in the Milky Way galaxy, and enough interstellar dust to make 100 billion more. We're not likely to run out of stars anytime soon. There is a distinct advantage to having so many stars. Current theories of stellar formation seem to indicate that most stars will have planets. 2. Milky Way could contain millions of planets, and each sun will have a Goldilocks zone. In other words, it's possible that most stars will have a planet that will fall in the habitable zone for life, where it's not too cold and not too hot, it's just right. It could have liquid water if it's solid. Even if it's a gas giant, it could have water in the atmosphere, so that something organic could float and live despite the lack of surface. 1. Frank Drake and alien civilizations. Drake was a radio astronomer who was intrigued by the notion of extraterrestrial life communicating deliberately by radio. He set up a conference and created an equation to stimulate discussion among the attendees. It was never intended to represent reality, but to help people consider just what we need to know in order to seek other life in the galaxy. Some elements we know and can compute, others are best guesses. Either way, all the equation shows is that there might be hundreds or even thousands of civilizations in our galaxy. But because civilizations rise and fall over time, they don't all exist simultaneously, and most will be nomadic or agrarian, but not technologically capable. If there are technological civilizations, they should number about 43 at this point in galactic evolution. With fairly even but random distribution, they are probably about 40 plus light years apart. Unless we're particularly lucky, we probably don't have a nearby neighbor. In fact, assuming we're average, that means there are 21 civilizations that are less capable than us, and 21 that are more capable than us. That is not a big pool to draw from, but it is possible that we might someday make contact with another alien civilization. Thanks for tuning into StarBurst. We hope you've enjoyed this video and learned something new about our incredible universe. Don't forget to subscribe to our channel for more exciting content, and hit the notification bell so you never miss an episode.